Welcome back, friends. We are on part 2 of graphing our shadows for Lab 3.3c. So yesterday, you guys should have got all of your shadow recordings. So you had your thing sitting out all day. Here's what mine looks like because I use a flashlight, so my shadows were a lot bigger. On each thing, I have kind of like the times in which I took them, and I also wrote. You were supposed to take a ruler, and if you haven't done this, if you didn't do it yesterday, you can do it today. But you basically take a ruler and you measure from the middle, and you measure in centimeters how long your shadows were. And you need to have those three lengths in centimeters. So if you haven't already measured them, go and do that now so that you have three sets of numbers so that you can make your graph. Because for the backside of this lab, it says, decide how you use your data to make a graph. I recommend using a line graph, and that's what I will be showing you guys today. With the time of the day along the x-axis, so that's left to right, and then the length of each shadow in centimeters on the y-axis. And be sure to label each axis and give your graph a title. I probably should give my graph a title. So my graph's title is just going to be graphing shadows. There we go. Kind of hard to write through the camera. All right. So let's go ahead and look at the graph first, and then we'll answer the question. So here on the x-axis, I have time of day in hours. Okay, these are approximately half a centimeter in distance. I just took a ruler and measured each one of these as a centimeter, and then in between each one, basically, I also put a dot. And then I went all the way from 1 in the morning. I guess the 0 could have been midnight. 1 a.m., 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12 noon. And then I did another 12, right? 1 in the afternoon, 2 in the afternoon, all the way to 12 at night. Okay. And then on the y-axis, I have the length of my shadows in centimeters. And my range was as long as it needed to be. A really easy way to do this is you just put a line on each of the lines in your notebook paper first. Boop, see? And then I just did a little line in between. So I went like 1, 2, 3, 4, all the way up. And then I didn't have any shadows that were longer than 25 centimeters. So but as you can see, I had plenty of room to go up even higher if I needed to. Okay. All right, so now we needed to graph the length of my shadows. So my first shadow measurement was taken at approximately 8 a.m. And that shadow was 25 centimeters long. So I go over to 8 a.m. in the morning. I take my straight edge and I go all the way up. I make sure it's nice and straight. And I went to 25 centimeters. I plotted my line, and that'd be my first point. I have more than 3 here, but you only need 3 in order to be able to see the pattern that's important. Okay. My next shadow was at 10 in the morning, and I measured that one, and it was 22 centimeters. My next shadow was measured at 2 o'clock in the afternoon, and that one was 13 centimeters. And then my last line that I measured, I keep saying line, my last shadow that was measured was at 4 o'clock p.m. and it was about 22 centimeters. All right. So yours might just have 3 dots, which is fine. You did one in the morning, one in the towards noonish. This actually should say noon. My bad. And then you have your last one in the afternoon at some point. All right. And what you're going to see is the graph starts to give you kind of an upside down mountain shape, like a valley. And this is important, that yours resembles this shape. The closer you get to noon, the further down we go, and the closer we get to bedtime, okay, starts to get longer again, and then this one's early in the morning. All right. So now we can get on to our conclusion questions now that we have our graph made. Okay, so number 3, and this will be done in your notebook here. Summarize how the shadow changed throughout today. So basically between morning time and like noonish afternoon time, the shadows got smaller. See? Early in the morning, that shadow was long. And then the closer we got to lunchtime, the shadow shrank considerably. Okay? And then as we got past lunchtime-ish time, okay, the shadow started to grow again. Okay, do you see this pattern? Do you see how the shadow changed? Okay. So it also changed in position. It pointed toward the west in the morning and then started to point more toward the south around noon. And then the shadow pointed toward the east in the afternoon. And I'll kind of show you what that looks like here in just a moment. Okay, so number 4. Infer what caused the changes in the shadow that you observed. Use evidence to support your inference. So the Earth rotates, okay, and the sun seems to change position from across the sky, but the sun's not actually it moves. It's the Earth that's spinning. The sun stays in place, but because the Earth is rotating, different parts of the Earth get different direct sunlight at different times. So this is what causes the shadows to change, or to change in length and position. Okay. So I'm going to kind of show you this now. So I used a flashlight for mine. Okay, so I'll use a flashlight, not for its light source, but for its shadow source. So sun rises in the east, right? So this is what it was like in the morning. Nice long shadow. Okay, sun rising from the east side. Now as the Earth rotates, the sun appears to move, but it's not really moving. It's the Earth that's moving. And as we get closer and closer to noon, you could see the shadow begin to change. It appears to shrink. See how much shorter that is? Okay, during the lunchtime hours. And then sorry if that's really bright, as the Earth continues to rotate, you can see the shadows start to get really, really long in the afternoon, in the evening, okay, as the sun sets in the west. I'm sure you guys can remember walking home in the afternoon on a nice summer evening and looking at your super long shadows in the grass. I know that I have many fond memories of playing outside and seeing that and being like, wow, I have a really long shadow. Ha ha ha, I'm a giant, right? That's why your shadows are so long, because of the direct sunlight shining off to the side. Okay, so you can see in fast mode, whoop, the shadows move as the light source shines from a different angle. Okay, pretty neat, huh? Okay. So number 5, suppose you repeat this investigation next week. So if we were to do this on a different day again, predict how your results would compare to today's results. Explain your prediction. So do you think they'd be different, or do you think they would be the same? Is there any reason they should be different? Does the day and night cycle of the Earth change? Or does it repeat itself every 24 hours? If you're thinking, well, it's the same, Mr. Hannon, the sun moves across the sky or appears to because the Earth is rotating every day, you'd be correct. Okay, the results would be similar because the patterns of our Earth's rotation and the sun shining on it from different angles in the sky, it happens every day. So you would get similar results to this. Okay. All right, friends, that one was a fun one. I enjoy that one. It gets us outside. If we were at the school, we would have done this outside too. It would have been pretty neat. So I will be online today in Google Meets from 1 to 2. If you guys have any questions about how we made our graph, if your graph does not look like my graph, or if it doesn't have the same V shape, we can take a look and see what's going on with that. And then we will also be having a little Google Meet social with everybody from 2 to 2:45 today. If you guys want to drop in and say hello and see everybody, that'd be awesome. I'll even show you Nunu.
No. There he is.
Look at the camera for the kiddos. Oh, he's too cool for school.
Kitty. Nunu says bye-bye. Oh, there he is.
All right. You guys have a good day. We'll talk to you later.